Hello students, in previous lecture what we have done, we have started with equilibrium. What we have discussed, equilibrium means what are the conditions of equilibrium, then what are the equations. In equations what we have discussed is what simple summation of forces along x-axis 0, summation of forces along y-axis 0 and summation of moments about any point equal to 0. This one we have done. What we have discussed, important part is what? Free body diagram. Means when we will remove all the supports, then we will represent what? Support reactions. And reaction acts in which direction? Opposite to the direction of restriction. When reaction comes into picture, or when we will get reaction on any body, whenever motion of any body is restricted, then we will get reaction in opposite direction of its restriction. And from that on we will discuss what 3, 4, 5 types of supports and how to represent support reactions. First type of support, frictionless or smooth support. Reaction in which direction? Perpendicular to contact surface and towards body. Second type of support, hinge support. How many reactions? 2 components of reaction, one horizontal, one vertical, and normally we will assume it in rightward and upward direction. Roller support, only one reaction. In which direction? Perpendicular to contact surface and towards body, only one reaction. Next is fixed support, we will get 3 reactions, one horizontal component, second vertical component, and third is what? Resistive movement, right? And last type of support what we discuss, any body supported by cable, wire, rope, chain. Reaction always acts along the axis of the cable and away from body. If you are not watched previous video, please go through it so that each and everything is explained in detail, so that you will understand properly this lecture. In this lecture what we will do, we will discuss about equilibrium of beams and we will solve some problems on equilibriums of beams, where normally most of the times similar type of problems asked in university exam, or we will solve some problems from previous recent university exam also. Okay. So should we start now? Yes. The first very simple problem, that is on equilibrium of beams. Equilibrium of beams. And listen carefully. If possible, when I'll represent here any problem, try to draw free body diagram, try to draw FBD, and then try to apply equations of equilibrium. And then what answer you will get, just check with my answer so that you will understand, and then it's possible to solve any unseen problem, right? Any new problem is given, easily solution is possible. And what you have to use, only conditions of equilibrium. Okay. First problem now, length of beam here given is what? This one is a beam having some length. Length of this beam is 9 meter is given in this problem. Okay. So 9 meter means I will divide in 3 parts. This is a 3 meter, 3 meter and 3 meter. Okay. Length of beam is what? 9 meter. So this length I will represent here 3 meter, next 3 meter and next 3 meters. This is 3 meter long, first part, again 3 meter long, and on this beam different types of loads are given, various forces are acting. This is 9 meter long beam. On left side here one support is given. You know this one is which type of support? This one is hinge support. Name of this support is A. There is one more support at right end and it is represented something like this. There are some rollers here. This is which type of support you are recalling? Yes, this one is roller support. Hinge support and roller support. You have to find out the support reaction when some loads are acting. What loads are acting? So here one force 10 kilonewton is acting here in downward direction. This is 10 kilonewton. One more couple is also acting here. So this one is a couple which is anti-clockwise, and this magnitude is 5 kilonewton meter. Is correct? Yes, 5 kilonewton meter. Then there is one load which is inclined here, inclined at an angle of 45 degree. Inclined at 45 degree. Magnitude of this load is 8 kilonewton. And there is one couple acting which is clockwise here, and this one is 6 kilonewton meter. This is the problem. Okay, this problem is from May 2010, Mumbai University problem. May 2010, right? Problem is from university exam. Ask for 8 marks. Okay, and what you have to find out? Simply reactions at supports. Okay, how to find out support reaction, that is important now. First important, this is a given problem. When we will start with solution, will not represent the supports. What will do? Will represent support reactions. So if you want to represent support reaction, this support which was given, that means while starting solution of problem, actually problem was given and will start with solution, so will not represent here support. What will represent? Support reaction. So this is hinge, means what will represent? Horizontal and vertical components. Horizontal means x, vertical means y. Rx and Ry. Simple. Next support is roller support. The motion of A and B is restricted in downward direction, so what will get reaction in upward direction. That means here if I will represent what is the support reaction, so here for roller support will get only one reaction perpendicular to contact surface and towards body. So this one is nothing but what? RB. This is reaction RB. In problem, what you have to find out? In all problems of equilibrium of beams, mostly in 99% cases you have to find out support reactions of beams, means reactions at A and reaction at B, RAX, RAY and RB. This one is our target now. Simple. Conditions of equilibrium are 3: summation of Fx equal to 0, summation of Fy equal to 0 and summation of moments equal to 0. Mostly initially we will apply moment equation. What is the advantage of applying moment equation here? If we will select moment center such that moment of two unknowns becomes 0, listen carefully. We will select moment center such that moment of two unknown forces must be 0. Total number of unknowns 3. Moment of any two unknowns becomes 0. Then in moment equation we will get only one unknown, right? That means how to select moment center? Select moment center such that moment of two unknown forces, means here two reactions, become 0, and easily you can identify such point. At this point A, if we take or if we apply our moment equation, sum of moments about point A equal to 0, the line of action of RAX passes through A, line of action of RAY passes through A, the moment of RAX and RAY becomes 0. That means there is only one unknown term now, that is RB. Easily you will find out. Now how we take moment, right? Sum of moments about point A equal to 0. If you don't know moment, there is one separate video on moment of a force and number of cases are discussed, so that you will not face any difficulty. Okay, if you have not gone through that video, please watch that video, so that moment you will not face difficulty in moments of forces. Moment of Rx, Ry 0. 10 kilonewton downward force, you are taking moment about point A. So due to 10 kilonewton, assume there is a horizontal bar, hold it at moment center, apply force in downward direction. How this pen will rotate? Clockwise. That means moment of 10 kilonewton about point A is what? Clockwise. Clockwise moment we used to write by what? Minus sign. Sign convention is what? Anti-clockwise moment positive. 10 into line of action of force vertical, perpendicular distance horizontal, means 10 into 3 clockwise movement. First term. Second, couple anti-clockwise. Simply what we have to do, as per its direction we will write with plus minus sign. That means this becomes what? Plus 5. Is minus 10 into 3 plus 5. There is a 6 kilonewton clockwise couple, minus 6 clockwise. How will take moment of 8 kilonewton? So 8 kilonewton is the inclined force. What we'll do? We'll resolve one component horizontal 8 cos of 45, one component vertical. So this one component becomes what? 8 sin 45. Moment of 8 kilonewton if you want to take, will resolve it in two components, horizontal and vertical. Line of action of horizontal component passes through A. That means moment of horizontal component is 0. Moment of vertical component about point A. How will decide? Horizontal bar 8 sin 45 is in which direction? 8 sin 45 downward. How pen will rotate? Clockwise. That means 8 sin 45 into line of action vertical. This is 6 is horizontal distance. For vertical force, perpendicular distance horizontal. 8 sin 45 into 6. Direction of movement clockwise. That means we will write with what? Minus sign. Moment of horizontal component 0. 6 already clockwise है तो minus. And moment of RB about point A if you want to take, hold it at A. RB is in which direction? Upward. How will get movement? Anti-clockwise. Means plus RB into force vertical, perpendicular distance horizontal. How much distance? 9 meter. Means RB into 9 equal to what? 0. That means if you write this equation, sum of moments about this point A equal to 0, taking anti-clockwise movements positive. This is our equation of equilibrium. Chalo, now simply we will write all these terms. Minus 10 into what? 3. Minus 10 into 3. Couple anti-clockwise plus 5. This one 6 is what? Clockwise minus 6. Moment of horizontal component 0. Moment of vertical component clockwise minus 8 sin 45 into what distance? 6 meter, right? And moment of RB anti-clockwise plus RB into 9 equal to what? 0. Using calculator simply find out. So this RB comes out to be, I already calculated here. You just calculate and see what answer will get. That is 7.216 kilonewton. 7.216 kilonewton. Now this direction of RB what we have taken here upward, this is assumed direction. After solving this equation, if you will get positive answer, assumed direction is correct. In case you will get negative answer, assumed direction is wrong, means correct direction is opposite to that one. So this one positive answer means assumed direction is correct. So what will get RB? 7.216 kilonewton. Okay. Now this one is known. RAX, RAY is unknown. Now it's very easy. Summation of Fx equal to 0. If you will apply, we will get what? RAX. That means next equation what will apply? Summation of Fx equal to 0. Assuming rightward force is positive. How many forces are acting along x-axis? Means in horizontal direction. Ek RAX which is rightward. Rightward means what? Positive. Plus RAX. Plus RAX. Number 1. Component of 8 is also acting rightward. That means plus, this will be what? 8 cos 45 equal to what? 0. That means what will get here? RAX definitely will get with minus sign. What will get RAX? 5.657 kilonewton. Negative answer represents what? He assumed direction of Rx which is rightward. This one is wrong. What will be the correct direction? Leftward. That means again I will write with positive sign plus 5.657 kilonewton and I will add here direction. That is what? Leftward. Clear? Whenever you will get positive answer, assumption is correct. Whenever you will get negative answer, assumed direction is wrong. Now next is what? Summation of Fy equal to 0. Assuming upward force is positive. So along y-axis, Ray upward, Rb upward means Ray plus Rb. 10 kilonewton downward minus 10 and component of 8 downward means minus 8 sin 45. Only 4 terms. First term plus Ray plus Rb minus 10 minus 8 sin 45 equal to what? 0. Already RB you have calculated, we'll substitute here and we'll find out what RAY equal to. So RAY comes out to be how much? RAY comes out to be 8.44. 8.44 kilonewton. This answer what you are getting is again positive. Therefore, what will represent here? Direction is what? Correct direction upward. Okay. Now, whenever we will get some two components, RAX leftward you are getting, RAY is vertically upward. So find out resultant reaction. एक leftward आ गया, one is what? Vertical. That means we will get resultant reaction in second quadrant. And RA comes out to be what? Square root of RAX square plus RAY square, and inclination of reaction with horizontal theta. How will find out? Tan inverse of RAY upon RAX. So resultant reaction you find out yourself, right? Important is what? How to apply moment equation, how to select moment center, and then perpendicular distances properly you have to represent. Force vertical, perpendicular distance horizontal. If force is horizontal, perpendicular distance is what? Vertical. Anti-clockwise movements are considered as positive. That means automatically clockwise movements becomes what? Negative. Okay, done. So this one is our first problem. Chalo. Now next, all your written. Most of the problems are from university exam. Okay, most of the problems. So this one is our first problem we are done. Chalo. Next problem, second problem we'll solve now, where again year of exam I am not recalling, but it is from university exam. Total length of beam in this problem what is given is 7 meter. Total length of beam is 7 meter. I will represent here 7 meter long beam. It is divided in some parts. First it is 3.5 and 3.5. This is 3.5, this is 3.5, and 3.5 is again divided in three parts. 1.5, 1, 1 means 1.5 you can say 1. I will first represent here lengths, right, so that while taking moment you will not face any difficulty. So this one is the length total, this one is 1.5, next is 1, again next is what? 1 meter, and next is what? 3.5 meter. This is 3.5 meter, this is 1 meter, this is 1 meter, this is 1.5 meter. Okay, what supports are given? So on left side here, one support what is given, you know this support is called as what? Hinge support at A. But at B what support is given? It is something like this. It is a roller, but not on horizontal plane. It is on inclined plane like this. This is a support, inclined support, and its inclination is given as what? This angle is given as 30 degree with horizontal. Okay, inclination is what? 30 degree. Name of the support is what? B. In this 3.5 meter what is given? So there is one, which type of load? Uniformly distributed load, and magnitude of this load is 40 Newton per meter. Okay, some more loads are given here. In 1.5 meter what is given? The load is something like this. So when such load is given, you know this is called as what? Uniformly varying load, and this magnitude is 55. Okay, 55 Newton per meter, acting in what distance? 1.5 meter. Next what is given? There is one vertical bar which is attached to this horizontal bar, and this one is again horizontal. Something bar is given like this. Dimensions which are given, that is 1 meter and 1 meter. That means this end is up to this location. Same vertical line. That means horizontal part is what? A 1 meter, and vertical also 1 meter. This one is also 1 meter. One here, na? Okay. Yes, 1 meter. Now there is one couple acting. One couple here. There is one couple here clockwise. How much? 125. Okay, this is 125 Newton meter, and at this end one force is acting which is inclined at 60 degree. This one is inclined, magnitude of force 60 Newton, inclined at an angle of 60 degree. Yes, that means while taking movement you must be very careful in this problem. Okay, any forces missing, just check. No. One UVL, a couple, one point load, one UDL, roller is on inclined plane. Ready? Yes. First will represent what? Support reaction. This is a hinge support. When your hinge support is given, what will get? Two components of reaction, horizontal and vertical. When we'll start solving problem, will not represent this support. What will represent? Support reaction. That means hinge support, so what will get here? Horizontal component and vertical. All you are getting this one? Yes, this is RAX. This one is what? RAY. Now for roller, you know reaction is always perpendicular. That means we will get reaction perpendicular to plane. See here, this one is not a difficult part. Here, plane is inclined at what angle? Plane is something like this. Inclined at what angle? 30 degree. A plane, right? Now this one reaction is perpendicular to plane. That means this angle is 90. Simple triangle. If you try to construct here a triangle, 30, 90. What about this angle? It is 60 हो गए ना? With horizontal 60. With horizontal 60. With horizontal 60, the same line with vertical what angle? 30. Okay, or you can say any plane is inclined at an angle of, see here, again I will represent here. Suppose this is a plane inclined at theta. If we will draw perpendicular to it, with vertical what angle will get is same with vertical. This one is with horizontal, with vertical it remains same, doesn't change. In most of the cases, we will get some inclined plane and you have to draw perpendicular. We will not construct triangle each and everything. You know any plane is inclined at theta with horizontal. If we draw perpendicular to it with vertical, angle remains same. That means in this case now, if I want to represent what? Reaction, support reaction. What will do? Plane is inclined at what angle? 30 degree. I will draw a line perpendicular to plane. That means this is vertical. Okay. If I draw perpendicular, this one is your end B, that means this is RB. What angle will get here? Same inclination of plane with horizontal was 30. What will get? Inclination as 30 with vertical are represented. Is this clear? Yes. I think this one part, for this one I explained separately, right? Any plane is inclined at theta with horizontal. If we draw perpendicular to it with vertical, angle remains same. Clear? Yes. Now one UVL and one UDL, whenever distributed loads are given, what you have to do? You have to convert these distributed loads into equivalent point load, which is simple, UDL. For UDL, equivalent load always will get at center of its span. Span means in which portion load is acting. It is acting in 3.5 meter. So equivalent of this UDL, you will get at its center. That means this distance is half of 3.5. Half of 3.5 means how much? 1.75 meter. Okay. Magnitude of load W into L. W how much? 40. L is what? 3.5. That means 40 into 3.5. 120, 140 Newton. Clear? 140. Next, what is important? Again, equivalent of what? UVL. Equivalent of UVL, if we will represent, you check. At one location it is 0, at other end here it is 55. Where it is maximum? At this location. Equivalent of UVL will get nearer to maximum load. That means nearer to this point. Name of points are not given. I will put here, say point C. From C nearer. Nearer how much? So it is same as that of centroid of right angle triangle. 1/3 of its span, 1/3 of 1.5. How much? 0.5. Means from C 0.5, from A 1 meter, I will represent here this load where this distance is 0.5 meter and from A distance is what? 1 meter. 1 meter and 0.5 meter. Okay. Now this load is area of triangle, you can say half of base into height. That means this will be half. Base is what? 1.5. Height is what? 55. Find out this one, how much will get? 0.75 na? Into 55. 41 point something आता है. 41.25. 41.25 Newton. Is this clear? Yes. So what is important? First will represent support reaction. Anywhere there is a distributed load, convert it into equivalent point load. Once you will get equivalent point load, now next step, you have to find out Rax, Ry and Rb. How will find out Rax, Ry and Rb? We'll select moment center so that moment of two unknowns becomes 0. So here also if you take moment at A, moment of Rx and Ry is what? 0. So that what we'll do, first equation I'll apply here, sum of moments about point A equal to 0. For each force I'll explain how to take moment and I will write that each term, right? Because applying moment equation is very, very important. Okay, applying moment equation is important. Chalo, first moment part. Sum of moments about point A, ये तो गिरना ही है भाई. Okay, ठीक है. हाँ, yes. हाँ. Now about point A, moment of 41.25. कैसा आएगा? Clockwise. Moment is what? Clockwise. What you have to do? Hold it at A. Apply force in downward direction. How this will rotate? Apply force downward. How this will rotate? Clockwise. Yeah, clockwise. Minus 41.25. Distance is what? 1. This one is moment of first force. Move on the right side. Yes, there is a couple. Couple means as per direction. This is what? A clockwise hai. Clockwise means what? Minus. Minus how much? Minus 125. Minus 125. Now there is a 60 Newton force. That is inclined force. For inclined force, perpendicular distance is not available. So what we'll do? I'll resolve. This one is a sine component. 60 sine 60. This is what? 60 cos 60. I'll write here. Huh? 60 cos 60. This is 60 sine 60. Take separately moment of these two components, because moment of any inclined force is equal to what? Moment or sum of moments of its components. Now 125 you have taken minus. So vertical force है. Force vertical, perpendicular distance horizontal. Line of action of 60 sine 60 vertical. If we measure what is the distance of this line of action of force from A, so 1.5 plus 1 plus 1, how much? 3.5. Moment of vertical force about point is what? Clockwise. Minus 60 sine 60 minus 60 sine 60, distance 3.5. Okay. Moment of horizontal component if you take about point A. So what you have to do, where force is acting at this point? Imagine A and these 2 points are connected. What will get? Inclined bar. Incline. Apply force in this direction. How this will rotate? Anti-clockwise. 2 points are important. Point of application of force and moment center. Approximately inclined bar you imagine. Hold it at moment center. Apply force in horizontal direction. So what will get? Anti-clockwise. So 60 cos 60 into, this is a horizontal force. So what is the distance vertical? How much is the vertical distance? 1 meter. That means plus 60 cos 60. 60 cos 60 into 1. 60 cos 60 into 1. About point A, if you take moment of 140, this is easy. Clockwise minus 140 into distance. This is how much? 3.5. This is 1.75. 3.5 plus 1.5, 5.25. 5.25. Anti-clockwise ke clockwise, clockwise movement. Moment of RB if you take, one component horizontal RB sin 30. So line of action of RB sin 30 passes through a, moment of horizontal component of this RB becomes 0. Horizontal component leftward, line of action passes through what? A. So moment of horizontal component becomes 0. Moment of vertical component, if we try, this is a vertical component which is RB cos 30. This one is RB sin 30. Moment of RB sin 30 is 0. The moment of vertical component, again same thing, hold it at A, apply force in upward direction. How this will rotate? Anti-clockwise. Anti-clockwise movement. RB cos 30 is plus RB cos 30. What is the distance? Total distance. Vertical force, horizontal distance is the perpendicular distance. This one is 3.5 plus 3.5. How much? 7. This equation clear? Okay. Taking moment is very, very important, right? Force vertical, distance horizontal. Force whenever there is a horizontal, perpendicular distance is what? Vertical. Now, after solving this one, we will get some RB equal to. Units are in Newton. What unit of RB will get? That is in Newton, and this one comes out to be 173.72. 173.72 Newton. And what answer you are getting is positive, that means this direction is correct. You can represent direction of RB something like this. This is RB and angle is what? 30 degree, as it is, right? Correct? This is your RB. Other part is comparatively easy. Next is what? We will try to find out RAX. We will apply equation along x-axis, summation of fx equal to 0, assuming rightward force is positive. Now concentrate on all horizontal forces. Ek RAX here rightward, component of 60 leftward, component of RB leftward, 3 forces. Means first one, what will write? Plus RAX, number 1, plus RAX. Component of 60 leftward, minus 60 cos 60. RB sin 30 leftward, minus RB sin 30 equal to what? 0. RB will substitute here, what will get? RAX, definitely answer is positive because both terms are negative. If we write these terms on the right side, becomes what? Plus. So what RAX will get? 116.86. 116.86 Newton. Answer positive means what? Rightward. Clear? Yes. Next we will apply equation along y-axis and we will find out what? RAY, summation of Fy equal to 0, assuming vertically upward force is positive. Now concentrate on all vertical forces. RAY upward, 41.25 downward, 60 sin 60 downward, 140 downward, RB cos 30 upward equal to 0. First I will write here RAY and I will write RB cos 30. Upward, positive. RAY upward, RB cos 30 upward, positive. 41.25 downward, 60 sin 60 downward, and 140 downward equal to what? 0. Just check what we written is correct or wrong. RAY upward, correct, hai na? RB cos 30, correct. 41.25 downward, negative. 60 sin 60 downward, negative. 140 downward. RB will substitute here, what will get? RAY is possible, so what RAY will get here? If you calculate, just check what will get. 82.76 I am getting here, 82.76 Newton. Answer positive way, that means what? Vertically upward. Okay, clear? That means actually solving problem is not difficult. Most important is what? First we have to draw what? Free body diagram. Once we will draw free body diagram, next part what is important? How to take moment of forces. Okay, chalo, one more problem we will try. Next problem. So this problem is from December 15 exam. Next problem, this is from December 15, right? This is our third problem. In this problem, what is given? One bar having what length? Let me check. 3 plus 2, 5, 5 plus 3, 8, 8 plus 4, 12 meter. So I will represent one bar having length equal to 12 meter. Okay. this is 12 meter. 12 means this one is what? Half. 6. This one is what? 3, 3, 3, 3 are divided. What lengths are given? First, what is given? 1.5 and 2.5. 1.5. First length I will represent here 1.5 meter. Next is what? 2.5 means approximately here. 2.5 meter. 1.5 meter and 2.5 meter. Next is what? 3 meter. That means this one is nothing but what? Okay. This one is 3 meter. 4 plus 3, 7. Okay. This one is 3 meter. 1.5 meter, 2.5 meter, 3 meter, then 2 and 3 meter. So this one is what? Is supposed to 2 meter, and next one is what? 3 meter. Here 2 meter and 3 meter. This is the length. Distances always represent properly, because distances plays very important role in what? Movement. Movement is very, very important. Support at A, what is given is again hinge support. This is A. Other support which is given, that one is not at the end, it is given somewhere here, and this support is a roller support which is given 3 meter from other end, and this one is given as say B. Supports are at A and B. Other forces which are given, so one uniformly varying load is given in last 3 meter. This is UVL. Magnitude is what? 24 kilonewton per meter. This is 24 kilonewton per meter. Number 1. Next, what is given? 1 kilonewton force at 1.5 meter. This is 1 kilonewton. Simply a point load is given. Next, at 2.5 meter, what is given? In this 3 meter, there is one UDL. In this 3 meter, there is UDL. UDL. Magnitude of UDL is given as what? 24 kilonewton per meter. 24 kilonewton per meter. Okay, 24 kilonewton per meter. And there is one couple acting which is anti-clockwise. Magnitude is what? 18. Okay, yes, it is 18. 18 kilonewton meter. Okay, 18 kilonewton meter. Now, all forces were represented? Yes. Okay. Now, next step is what? Support reactions. Support at A, hinge, I will remove support. What will add here? Two components of reaction, horizontal and vertical. Name of reaction RAY, name of reaction RAX. Support at B, roller. For roller support, what will get? Only one reaction perpendicular to contact surface. That means here reaction, what will get here? RB. Okay. Support reactions. Okay. Now, equivalent of UDL and UVL. Equivalent of UDL will get where? Always at its center. Center of what? Span. Span means in which portion that load is acting. This is how much? 3 meter. Iska half. 1.5 meter. Magnitude of load to W into L. W 24 and this is 324 into 3 comes out to 72. Aata hai na? Yes. This is 72. Equivalent of UVL from maximum 1/3. 1/3 of 3 means how much? 1 meter. This will be 1. That means this one distance remaining is what? 2. Total 3 hai na? Okay. Magnitude of this load half W into L. How much? 3 hai na? So what will get? 36 na? 12 into 3. Yes. 36 kilonewton. Perfect. Any problem in free body diagram? Yes. Everybody clear? Support reactions, equivalent of UDL, equivalent of UVL. Where will get equivalent of UDL? At its center. Where will get equivalent of UVL? Nearer to maximum load. 1/3 from maximum load. 1/3 of what? Span. Span is how much? 3 meter. Iska 1/3 लिया 1 meter. ये कितना आ गया? Remaining 2 meter. Magnitude of this load half of W into L. W 24. L is what? 3. Calculate किया 36. Equivalent of UDL, W into L. W how much? 24. L is what? 3. 24 into 3 how much? 72. Now, two reactions. Our line of actions of Rx and Ray passes through what? Point A. That means what we'll do? We'll take what? Movement about point A. Hello, try to find out moments about point A equal to 0, taking anti-clockwise movements positive. First, what we'll get? Moment at A if we'll take, right? First force. How much? 1. Clockwise ke anti-clockwise? Clockwise. 1 into what distance? 1.5. Correct? Moment of 1 kilonewton clockwise. Clockwise. Force vertical distance is what? Horizontal. So 1.5 meter is distance. Next, moment of equivalent load 72 का है ना, तो clockwise. What distance? This is a distance. This will be what? 4 and this one 1.5. 5.5 minus 72 into 5.5. Correct? Correct. Couple anti-clockwise plus 18. Plus 18. Movement of 18 एंटी क्लॉकवाइज प्लस भी रिटर्न. मूवमेंट ऑफ आरबी. आरबी का मूवमेंट कैसे आएगा? एंटी क्लॉकवाइज प्लस आरबी इनटू व्हाट डिस्टेंस? फोर्स वर्टिकल हॉरिजॉन्टल. 4 प्लस 3 7 है ना. 7 प्लस 2 9. Movement of 36 clockwise minus 36 into what distance? So this one is 4 plus 3 7. 7 plus 2 9. 9 plus 2. 9 plus 2 is what? 11. Correct है? Just check what I written is correct. So find out RB. So RB, this one comes out to be, I already calculated here, 86.17. 86.17 kilonewton. Answer positive है. That means this reaction is what? Assumed direction is correct. What will get? Upward. Clear? Moment equation is very important. The remaining part is easy comparatively. चलो, summation of fx equal to 0 assuming rightward force is positive. तो एक तो rx is what? Rightward. Means what? Plus. Check करो. Is there a horizontal? Or there is no horizontal force. If there is inclined force, we will get some horizontal component. There is nothing. That means Rx. There is no other force. Means Rx is what? 0. Very simple. Next, summation of Fy equal to 0. Assuming vertically upward force is positive. Now what we will get? Ray upward plus Ray. Rb upward plus. See here. Ray upward. RB upward plus अभी downward minus. How many forces? 3. Minus 1 minus 72 minus 36 equal to 0. Correct है ना? Minus 1 minus 72 minus 36 equal to what? 0. Now what we'll do? RB will substitute here है ना, 86.17 and we'll find out what? Ray. We'll find out what? Ray. Again this answer comes out to be what? Positive answer. 22.83. 22.83 kilonewton. This one is again upward. Clear? So this problem is also from university exam. So in this lecture now we'll stop here. Again in next one more video lecture I'll cover again some 2 to 3 problems from mostly university exam. Okay, thank you.